Hey there. We're going to be going over this article which is talking about numbers in a cyclic system. And just as a preface, this article isn't really going to talk anything about anything musical. Uh, the reason why we have this article is so that when we actually get using our system, we're going to be literate in it and we're going to know what's occurring. So let's just go through it and just remember this is purely about our system and the way the numbers work in it. It's not to do with notes, it's not to do with anything, but it's going to be extremely important later on as we start considering numbers as notes, as you saw in our first article. So the first thing we're going to talk about is addition and subtraction. So if someone asks you what's 2 plus 3, we're going to answer 5. But if someone asks you what's 10 plus 15, you'd answer 15, right? Or, sorry, 10 plus 5, you'd answer 15. But in our system, that's a little different. And the reason why is because we have this wraparound kind of thing going on. So let's just see what happens. So we have 10, right? And we're doing plus 5. So we would just be going 1, 2, 3, 4, 5, right? So in our system, when we do 10 plus 5, the answer is actually 3. And that's due to the fact that it wraps around after 11, right? Like if it didn't wrap around, well then we'd get 12, 13, 14, and then 15. Okay, so we know what adding is like. But what is subtraction like? Well, if you did 10 minus 5, then it's 5 as normal. And the reason why that's true is because you don't hit the wraparound point, right? So 1, 2, 3, 4, 5. If you never hit this wraparound point, then the addition and subtraction is the same as in real life. But let's try the other example. So 1 minus 3, right? So we're at 1. Then we go minus 3. So 1, 2, 3. Then 1 minus 3 is 10. So we can see in this case, once it passes that wrapping point, then we get a different answer. Because if you asked anyone else, they're going to say 1 minus 3 is 2, right? So just in our system, we have a little bit of different stuff going on. So addition and subtraction works like this, okay? Okay, so we've gone through addition and subtraction. And now, since we've considered already subtraction of numbers, like if we did 1 minus 3, that's the same thing as 1 plus minus 3. So what we're actually considering negative numbers, so we may as well start to analyze those as well. So if we had the number minus 3, it's the number which is 3 below 0, right? So what is the number that's 3 below 0? Well, if we start at 0 and we go 1, 2, 3, you get 9, right? So 3 below 0 is 9. And in that sense, we can say minus 3 and 9 are equivalent. And what this equivalent thing can occur for every number. So if we have the number 1, for example, why we have 1 is equivalent to minus 11, and why would that be the case? Well, if you have 1, and if you start at 0 and you go minus 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you end up at 1. Obviously, one way is much faster to think about, and one way is longer. So as you can see, like equivalent things can feel a little different. And then obviously with 2 you have 10 and so on following that process. And you'll see like first these numbers go, as these numbers go down, these numbers go up. So they reference the same number. So in a circle, minus 11 is the same as 1 because minus 11 is 0 minus 11, and that puts you back at 1 like we talked about. And we'll just take one more example. So y is 7 equal to minus 5. Well, if you start at 0 and you go 5 steps backwards, 1, 2, 3, 4, 5, you end up at 7. So these numbers are equivalent. And why is it interesting to have equivalent numbers? Well, it allows us to do stuff more efficiently. And let's add 10 plus 10 in our system, right? 10 plus 10. Well, what would we do normally? We'd start at 0, or sorry, we start at 10. Start at 10. And then we'd go around 10 times. But we know that 10 is equivalent to minus 2. Not minus 20, minus 2. And so instead of going around the circle like this, all we had to do was go minus 2. That gives us an answer of 8. And so being able to use the equivalent number actually turns out to solve questions a lot easier. We'll go through another example. So let's do minus 11 and then minus 8, right? So we know that if we're at minus 11, right? We want to go minus 8. So we'd be going counterclockwise around the circle 8 steps. Well, minus 8 is the same as plus 4, so we can really change this to this question. And that's easier because we go 1, 2, 3, 4, and our answer is 5, or minus 7. So that's equal to this, and that's equal to 5. Okay, so we've gone over how negative numbers work and how they represent equivalent positive numbers, and how they can help us be more efficient when we're solving questions like that. And now we'll get into what an interval is in our system. So it's the number of steps required to get from one number to another. So if we're wondering what's the interval from 10 to 3, well, all we gotta do, start at 10, and then we have our goal, which is 3. And now how many steps does it take to get there? So 1, 2, 3, 4, 5. So the interval from 10 to 3 is 5. So having the circle around is going to be really useful, but we're not always going to have that circle around. So what we did is we said, what do you add to 10? So that's the question mark. What do you add to 10 to get 3? And the way we could answer that is, well, if we add 2 plus 10, you get to 0. And then you add 3 more. And then so 10 plus 5 gives you 3. So that answers that question. And then another, if someone asked us to find the interval between 5 and 4, we're trying to figure out what we have to add to 5 to get to 9, right? So the interval between 5 and 9. So that's the same thing as x just being 9 minus 5. So we could just say, what do you add to 5 to get to 9? Or we can say, you add 9 minus 5. And that should make sense because 5 plus x equals 9. Well then, if you do 5, so we want to know the answer to 5 plus x equals 9. But we know 5 plus 9 minus 5 equals 9, right? Because these ones will cancel, and then you'll just get 9. So that number is always equal to 1 minus the other. And since right now we have to kind of talk a lot about, so I have to say, what is the interval between these two numbers? A quick way of writing it down is just going to be I 5, 9, and that would be equal to 4. So that's kind of our shorthand way of doing this. So now we know what I59 is, and then we're going to try and solve I95, and we have to figure out what we have to add to 9 to get to 5. So around the circle, what we know is if we start at 9, we want to get to 5. We know if we go 3 steps forward, we get to 0. And then if we go 5 more steps to 5, right? So, or we go 1, 2, 3. So I think I just messed that up a little bit. So start at 9, you go 1, 2, 3, get to 0. You go 1, 2, 3, 4, 5, right? So in total, the interval between 9 and 5 is equal to 8 because 3 and then 5 more. Although that was kind of a lengthy process, we already had this shortcut, right? So we had the shortcut, which is the interval between two numbers, which was 9 and 5. Then what we can always do is do this, because what you have to add to 9 to get to 5 is that. Because that cancels again, and you just left with 5 on this side. So when we wonder what this is, it's 5 minus 9, and then in our system, that'd be minus 4. Also, let's just go through this. So in this case, it's easier. Yeah, so another way of seeing it is if we go back to the circle, we're at 9, we want to go to 5. Well, we could have just gone backwards 1, 2, 3, 4 times. And so the interval between 9 and 5 is also minus 4, just because of the different way we could have thought about it. So there's many different ways to think, and also our initial guess told us that this was 8, right? And we know that minus 4 and 8 are equivalent in our system, so that also makes sense. Okay. Now we've gone through what an interval is, and in general we kind of came up with this idea, which is like the interval between any two numbers, like x and y, that's equal to y minus x, right? And the reason why is because you're answering the question, what do I add to x to get to y, right? Well, x plus y minus x equals y, because again, those two cancel. Okay, so that explains this interval, this formula we have. Now, there's something else we need to consider, which is, it seems like when we've been working on stuff, there's always been like the short way around the circle versus the long way around the circle. And the small representation is exactly that. So let's just go over that one more time. If I told you to go 11 times around the circle from here, like clockwise 11 times, you would just probably go back 1, right? Like there's no real need to go 11 times around when there's a shorter way around here, right? So if we're looking at 0, and if anyone just says, like they want to know, they want to go here, how many steps away is it? There's no real reason you'd count going this way, right? Because there's a shorter path this on the other side, right? So you would always usually take the short path, right? So if I told you, how do I get to here? You'd probably say go 3 leftward rather than say go 9 clockwise, right? So this small representation is exactly that idea. So instead of 1, So these two numbers are equivalent, but we can always choose the one that's smaller using a smaller number, right? So when we think of, let's say, this one, going 8 around is the same as going 4 counterclockwise. And so we would just choose that smaller representation. And so this small representation is just a way of us choosing the version of a number, either itself or its equivalent, the negative equivalent, but the one that uses the smallest number. And this is useful because the small number will help us just get stuff done a lot faster. So let's say we're interested in finding the interval between two numbers. So the interval between 10 and 0, right? So we're asking ourselves, if we just use the formula, that's 0 minus 10, right? Well, what's the small representation of 10 minus 10? It's 2, so you just write 2. And then the answer is 2. So whenever we have a hard question, we can simplify it because there's always a shorter way around the circle. And this small representation is exactly that. So if I were to ask you, what's the small representation of 8 minus 8? It's 4, right? And what's the small representation of 4? Well, 4 is already small, so it's still 4. What's the small representation of 11? Well, that's minus 1. And so whenever we get the small representation, it's usually easier to work with since it's a smaller number. So when we do our intervals, we remember that the interval between any two notes, x and y, or two numbers, is y minus x. But if this is a big number, then we're going around a circle. Let's say it's here and here. We'd be subtracting or going around the circle too far if it's a large number. So we can always just use the small representation of that interval to make things easy for us. So we'll just go through an example again, which is like, what is the interval between 11 and 3? Well, using our new formula, it's 3 minus the small representation of 11. And that should be, what's the small representation of 11? Minus 1. 3 minus minus 1, and that's 3 plus 1, which is 4. So as you can see, the small representation really saved us, because if we didn't use it, we would have had 3 minus 11, and then we would probably go back to our circle. We'd be like, okay, 3 minus 11, we start at 3, then we go around leftward 11 times, but we know because of the small representation, that's the same thing as just going here. So we've gone through this whole article, and I know this article kind of doesn't seem like it's going to be connected to music, but I promise you this will be important. This isn't just some random article. This is going to have direct connections to everything we do in the future. So if you made it through that and you have a few questions, that's totally fine. That's normal. Just feel free to ask them and we'll get stuff cleared up. So yeah.